this is Hiroyuki Tajima. So, so this is 4 times of the explanation of the Gross-Pitaevskii equation. So in this maybe I would like to explain how to calculate ground state energy of this system. So simply this is explained in terms of the wave function and the Hamiltonian. So yeah, actually I have already explained the structure of the many-body wave function of the condensate and the Hamiltonian. So just simply we are substituting this form into this formula, we can obtain this kind of the equation. So here, so this is single particle state. I mean this is now product of single particle state, and here this is single particle energy term, and this is the interaction term. So actually, we can simplify this expression by using some simple argument. So here, just recalling the normalization conditions. So then we can simply assume that so term which does not lead to the index of the Hamiltonian. So this integration is simply becomes unity because of this normalization condition. So then, so this first term can be written as like this. So summation of the each label and so integration of the some position and just simply expectation value of the single particle Hamiltonian. So next, second term is now involves delta function, and the summation is also involves the two labels. Then we focus on this two labels in the delta function. So then this summation can be written as like this. So here, in that case, we focus on these two labels, Ri prime and Rj prime. Then, so yeah, just for simplicity we realize Ri and Rj. But anyway, so this involves two wave function, phi star and phi here. So then now we consider the two variables for the coordinate. Then this second term can be written as like this. So I mean the phi Ri square and the phi Rj square times delta function. So now now integration is twice, but one of them can be performed by using the delta function. Then this Ri should be equals to the Rj. So finally we obtain this expression. So now you can see that so this Hamiltonian is equivalent even in the absence of this label of the coordinate. So then just simply we can multiply the n times the single particle energy as like this. Also we obtain the interaction term as like this. Now we use so just combination of the two particles from the n particle. Then this time now I also how to say write the n here. So then this term becomes like this: 1 over 2 n times n1 minus 1 that's over n. Then so now since we perform the integration for the delta function, so this label is now label of the coordinate is equals to the this equals to this term. Then we obtain the phi r power 4. So this is a basic expression for deriving the Gross-Pitaevskii equation. So in this movie, that's all. Thank you very much.